Okay, so this is the continuation of our previous class. We are discussing about the matter waves, and detection of matter waves has been explained. And now we go to Davison-Germer diffraction experiment and G.P. Thomson experiment. First, Davison and Germer diffraction experiment. The first experimental evidence of matter wave was given by two American physicists, whose named as Davison and Germer in 1927. This is the experimental setup of their first. The Faraday cylinder was moved on the circular scale. Here the Faraday cylinder is this, and it's moved on the circular scale, and for a given accelerating voltage, the scattering curve shows a peak in a particular direction. The scattering curve showed a peak, so this is the peak in a particular direction. With the electron beam incident perpendicular to the crystal surfaces, the pronounced scattering direction was found to be 50 degrees for electron accelerated to 54 volts. According to the de Broglie electron wave, lambda equals to 12.26 by root 54. Here root 54 is the volts, and that is equals to 1.67 angstroms. From X-ray analysis, it is known that a nickel crystal acts as a plane diffraction grating with the grating space d. This is equals to 0.909 into 10 power minus 10 meters. According to the experiment, we have diffracted electron beam at angle 50 degrees. The corresponding Bragg angle is theta equals to 180 minus 50, which is the difference, by 2, that is equals to 65 degrees. By using the Bragg's formula, we calculate the lambda, which is 1.65 angstroms. As the two values are in good agreement, hence confirms the de Broglie's concept of matter waves. And then another important experiment is G.P. Thomson experiment. G.P. Thomson performed experiments with electrons accelerated from 10,000 to 15,000 volts. In his experiments, he observed diffraction patterns exactly similar to X-ray patterns. So his diffraction patterns are exactly similar to X-ray patterns. Moreover, he was able to determine the wavelengths associated with electrons. This is his experimental setup. He had placed a cathode and a gold foil in between. He made a silt with a small gap, and he put the whole setup in the vacuum. After developing the plate, a symmetric pattern consisting of concentric rings about a central point are obtained. After this, in the photographic plate, after the experiment in the photographic plate, this type of pattern has formed. When the light is released in the vacuum through the silt, it got tacked to the gold foil, and the image is formed at the photographic plate. After developing the plate, a symmetrical pattern this is formed on the photographic plate. In order to make sure that the pattern is due to the electrons and not due X-rays, for this he applied magnetic field on the path of the electron beam in the discharge tube. A shift in the electron beam direction has been observed with the applied magnetic field. It shows that the pattern is produced by electrons and not by X-rays. The observed rings can be interpreted only by considering diffraction pattern of electron beam, which is due to the gold and aluminum foil. The following conclusions have been drawn from the experiment. Thomson experiment clearly demonstrated the existence of matter waves because the diffraction pattern can be produced by waves. Thomson calculated the wavelength associated with the electrons with the help of diffraction rings. The calculated wavelengths obtained by diffraction pattern agree well with the wavelengths obtained by de Broglie's relation. The associated wavelength depends only on the accelerated voltage is independent from the target material. And then the Heisenberg uncertainty principle, we are all familiar with it from our lower classes. The uncertainty was explained by Heisenberg in 1927. To understand uncertainty in measurement of position and momentum of microscopic particles, let us take an example and a narrow wide wave packets. In a narrow wave packet, the position of the particle can be precisely determined but not the wavelength. As a result, the particle's momentum cannot be measured accurately, as it is the statement which is said by the Heisenberg uncertainty principle, that we can't determine the exact momentum and the position of a fast moving particle like an electron. So thank you friends for listening my seminar. Thank you.